Is it recording? All right. Welcome, everyone. My name is Lila Kibrosi. I'm the current president of our chapter of BMES, and I'm going to start tonight by introducing our panelists. First, we have Dr. David Wong. He's a clinical research manager and research scientist in the Department of Neurosurgery at the University of Texas Southwestern Medical Center. He received his PhD and master's in electrical engineering from SMU in 2020 and 2018. Dr. Wong is a member of IEEE Eta Kappa Nu and the IEEE Signal Processing Society and IEEE Engineering and Medicine and Biology Society and the Society for Neuroscience. His research interests include therapeutic brain-computer interfaces and computational neuroscience and biomedical signaling processing. So please welcome Dr. Wong. We also have Maria Rudetsky. She received her BS in biophysics and is currently a second-year neurobiology PhD student at Duke University. She also conducts biomedical engineering research at the Summer Lab at Duke University. Welcome, Maria. Drew Schindler received his BS in mechanical engineering with a biomedical specialization and a BA in music from SMU. He was also the founding president of the SMU chapter of BMES, and he is currently a student at the Texas A&M Engineering Medicine program, earning his MD and Masters of Engineering. Welcome, Drew. Welcome back. And we have Cassie Hammond. She received her BS in mechanical engineering with a biomedical specialization from SMU. She's currently at Duke University earning her MS in biomedical engineering with a focus on medical device design. And she has been one of the original officers for BMES and was the president of our organization last year. So welcome back, Cassie. And last but certainly not least, we have Carolyn Du. She received her BS in engineering from Harvey Mudd College, and she is currently in the MS of biomedical engineering program at Duke University. Welcome, Carolyn. All right, so we will go ahead and get started. Please make sure that you all are muted. And like I said, if you have a question, please feel free to put it in the chat at any time or raise your hand and we will get to it as soon as we can. So I will start off the questions to each of our panelists. Why did you choose your graduate degree program? Dr. Wong, would you like to start?
Sure. To be honest, my undergrad degree was quite far from what I'm doing right now. It was telecommunications engineering. So at the time when I was applying for a graduate program, I honestly didn't know much, but I did know that for me, that electrical engineering is kind of an all-arounder. You can get familiar of all aspects of engineering. So I went by that. And since my stay at SMU, I met my advisor, who's Dr. Davila, Carlos Davila, who's been working on, biomedical field for a while. And I got involved and I figured I really like it. The electrophysiology, stuff like that. It's really, to me, it's a new world. And I figure, well, I would like to pursue even further than just a master's degree. So I ended up doing a PhD there as well. So that's kind of my story of the graduate program. I think you're muted.
Sorry, thank you. Maria, would you like to go next?
Sure. So my undergraduate degree was super rocky until I figured out what I wanted to do, which was still that I didn't figure out what I wanted to do. It was more that I understood that I liked kind of the middle route of all of the sciences. So that's why I picked biophysics. And my senior year, I worked in a lab studying visual ecology. So basically studying how deep sea animals communicate with fluorescent and bioluminescent signals. And I got very fascinated with optics. And so what I thought I wanted to do was medical physics and inventing a new optical machinery, etc. So when I started teching, that's what I started working on. And I started working in the field lab, which at that time was at Duke. And I started working as a very technical tech. I built a light sheet microscope together with a postdoc. But then slowly I got very intrigued in neural circuitry and how much that relates to computers almost. So basically, I understood that balance between sciences is not just something I can do to make a machinery to engineer, but also engineering neural circuits, for example. So I found neuroscience super fascinating and thinking about it as almost like electrical circuit and how that possibly could work. And the first year after teching, I told my mentor, there's no way I'm applying to neuroscience programs. And then after a couple more months, when I learned to code a bit better and it wasn't a nightmare for me, I was like, this is awesome. This is really cool. And that's how I ended up doing neuroscience. And one thing that helped me too was when I told my PI that I'm not sure because I don't think it's computational enough for me. And my PI told me, well, it's like so broad that you can be not doing experiments and just doing computational stuff versus doing just molecular stuff. And that just excited me to have that option open. So that road of all of the sciences still is like open for me to figure it out.
Wonderful. Thank you so much. Drew, would you like to go next?
Sure. So I went to SMU for my undergrad, and I knew that I wanted to get into the medical, like the biomedical space, because I thought it was really cool. But SMU didn't really, like, it doesn't have a biomedical engineering track. So I did the specialization. So I was a mechanical engineer and then doing basically just the pre-med classes. And as I was getting further or closer to graduation, and I kept taking these classes and doing fairly well in them. I was just like, I'm taking these classes anyways, might as well see or like continue to prepare like as a pre-med student for the MCAT and go through the application cycle. And I just got more and more involved in the medical side of things as far as you know, what opportunities SMU had to offer with their pre-health societies and pre-health organizations and all the support that they give on that side of things. And felt like I really liked it. And then I learned about the program that I am in today, which is Texas A&M NMed, where I get my MD in 4 years and also Masters of Engineering. And I thought that was very intriguing. So as I went further and further through the process, applied to med schools, applied to this school, got interviews, got in, and now I'm here. So I think it was a very step-by-step process for me. And it was kind of like you take the next step and then the next door opened almost. So I'm happy to get into it a little bit more as we go throughout this event. But
Awesome. Thank you for sharing. Cassie?
Yeah. So in undergrad, I figured out that I wanted to do biomedical engineering, but there are so many different paths you can take within that field, and I didn't really get exposure to those different options at SMU because we don't have that degree. So I felt like I needed to take actual biomedical engineering classes and see what all was out there. before I chose what I wanted to do. And I was also trying to decide between industry and getting a PhD. So I felt like a master's was a good middle ground. And I chose the medical device design specialty because I thought it would prepare me the most for industry. And I chose neural engineering research because it interested me the most when it comes to the academic route. So right now I'm getting to learn a lot about both industry and academia before I have to choose which way I go.
Awesome. Thank you. Carolyn.
Yeah, so for me, my undergrad degree was really general. Like it wasn't even a specific type of engineering, it was just engineering. So we had to take a bunch of different classes in different areas. And then I think I took a intro to BME class, like the only BME class we had there. And I got really interested in doing kind of more like biomedical applications of engineering. So that's why I decided to go apply for a master's in BME. And then not a PhD yet because I felt I wasn't really ready to dedicate like 5 years to it. So I think also I was interested in like medical device design because I'm from California and there's like a bunch of medical device companies there. So I figured like maybe it would help me like kind of stay in California after graduation. And then Duke has the medical device design certificate, as Cassie said. So ended up coming here.
Great. Thank you. For any of the panelists who took a gap year before you continued on to graduate studies, why did you choose to do so, and did you find it helpful? For this one, you can just unmute if you have a response.
I already mentioned I teched for 2 years, and it wasn't even a question that I need to go right back to school after undergrad, because one, I was exhausted from classes, and two, I didn't really know which graduate school I wanted to go to. And something I didn't do that much in undergrad, because I was also on the pre-med route, is research, which a lot of PhDs and my peers have done. And I knew that I just wanted to dig into it and see if that's something I really enjoyed before I committed to something that's a PhD. And it was fantastic. I mean, I figured it out what I wanted to do, and to actually go through a PhD, you really do have to have that interest in wanting to do it. So figuring out which exactly is the right place for you, I think is important. So taking some time, or even like Cassie's doing a master's before doing a PhD, is definitely a good thing. If I weren't gonna do a PhD and I'm gonna do MD, still I didn't know what I wanted to do after graduation, so I ended up in the PhD route. But it might have well been like 1 year of research and you figure out, no, I actually just want to be in industry. And then we had a tech in lab who was my year at Duke, who did 2 years of industry, now has done like 1.5 years of teching to go back to PhD. So I mean, the time is endless. So to really take some time off to figure it out, I think is a good thing.
Yeah, I can talk to this as well. I took a gap year before starting my program. I worked as a spinal product development engineer. So I think taking a gap year has a ton of benefits. I think just like Maria said, it's like you figure out what you actually want to do. For me, it was really helpful because I was a stronger application after my gap year, and just like taking time to not do an application while still doing full-time school, I think is a huge benefit, because any application cycle is exhausting with how involved it is writing essays and applying to however many schools. But I also think that it lets you mature as a person. which is never a bad thing. Not that going straight into a program is bad either, but I think that it just exposes you to a lot of stuff that you don't get exposed to when you're slaving away in undergrad. And then the final point is, I think that it's pretty much a trend that I think it's more common nowadays than it's not, to take a gap year, at least one, to either just take a break or work or do research or any combination of those things. So I think I felt that it was very positive.
To echo off of Drew very quick about the applications, I completely forgot about that. But especially if you're planning to apply to PhD, having had research experience is going to benefit you immensely. I don't know about MDs that much, but in terms of research applications, it's almost like the most important thing.
Yeah, I would like to add some points to this question. I think this is a really good one. Although my personal path, for me, I didn't choose any gap year, but over the years, students, undergrad, grad student, or math student in our lab, they all kind of have a, some gap year or certain duration of time. Some students wanted to go, say, math school. Some want to go for a PhD route. And like Maria and Drew said, it will give you a much more competitive background. And I don't want to encourage any of you, but being able to publish a paper in a certain area is very hard. For our lab, we had like a couple of undergrad students with the assistance of, PIs and all more of a senior members. We were able to publish some peer-reviewed articles in the field of neuroscience, which gave them much more leverage to apply for either math school or grad school. Matter of fact, it's kind of funny that every person I know wanted to go MD ended up being a PhD program and vice versa. So you will learn more about the stuff you were thinking, but at the time you didn't know much of a detail until you were doing the work, you found passions or something you don't like. It's a learning curve for sure. And another aspect I want to mention is that the thing is, if you go for a gap year, what if, is there a chance that what if you didn't publish anything? That could be a disadvantage than going for, say, pursuing a master's degree, that at least you'll have a degree in something. I mean, it depends on person that, if you really care about the degree or diploma itself, but it is an important aspect of that. And also, I have known some of my personal friends, undergrad students and stuff like that. They went to industry and never came back. The thing is, although they had ambitions to pursue like a tenure track after college and decide to go to the industry, but the thing is, industry paid much, much more than academia. And being able to work in a professional industrial setting gives you a lot of experience, which matters the most, I would say, when you're changing a career or something, especially for something like your programming, software development, that type of a position is really, really important. So I guess to conclude this, is that it really depends on your ambition, your determination, and what you want to go. If you're not sure, go ask someone like our panelists and ask them like what their stories look like, and if there's something match your your potential or your point of view for the near future. Thanks.
Can I just add to that? I think you hit a lot of really good points, David. Sometimes I wish that I could just go back to industry, if I'm being honest.
Same here.
Yeah. But I think that the working gives you a ton of value. I'll just talk specifically to working. So I feel like it gave me a lot of, I guess, like the corporate experience that I had never been exposed to before. And for me, like, I had spent 4 years of my life in undergrad training to be an engineer, and I felt that I like owed it to myself to at least try it out and say like, no, like I got the degree, I worked as an engineer and I did well, and I could have made that my career, but I'm choosing, like, the choice was important to me of like trying it out. And I think that I made the right choice of leaving, but it is hard sometimes when you're slaving away studying or in the lab working late hours, I'm sure, and you're like, wow, a 9 to 5 would be so nice right now.
Yeah, that's a good point. Yeah.
But that's my 2 cents on that. But
Wonderful. Thank you all for such detailed answers. Some of you already touched a little bit about the application process for graduate school, but could you all elaborate a little bit more on what that was like for you, or maybe some pointers about what you would have done differently or what would have been helpful to know during that application process? Dr. Wong, we'll start with you.
Oh, sure, thanks. I think my application process was slightly different than most of you, since at the time I was an international student. I had to take some extra exams and stuff to get some credit. But overall, to apply for the master's degree was basically, I would say, similar to when you were applying for a college. So you got all your paperwork, document, transcript, and everything, and send out the package to each of the school you're interested in. And to my PhD program is quite different, because at the time I spent, well, my master career doing research with my PI, and I was able to get a position there as well for the PhD program. So it is a really good leverage. And if I had to do anything different, I would probably do more of, I would say, communication before the actual application, to talk with the PI, to spend more time on the program website, to talk about, to check basically what those professors doing, and specifically send an email to them to do some networking thing to see if there's a better matched or better study that fit my personal interest as well. So that was my experience. And when I was doing applying for the PhD grad school, I did try different schools as well. But I kind of want to point out that going to a new environment, even though no matter how close to PI works, like in the field, they're quite different. And there will be a learning curve for you. There'll be some time you get there physically and mentally to be prepared for the new tasks or new study. Generally speaking, as far as I know, based on my own experience as well as some other students in our lab, I would say that could take about 6 to up to a year, 6 months to a year. So you have to factor that in your entire program. So with that in mind, so I decided to stay at SMU, and it really gave me like a lot of leverage. So I was able to finish my PhD in 4 years and be going out just to work like normally, like a normal person. No more late night working. So I hope that helps.
Wonderful, thank you. Who would like to chime in? You can just unmute.
I can just go. So I think what's quite different for applying, for not applying, but neuroscience programs and biomedical engineering PhD programs is that most neuroscience programs will have rotations. So you don't actually apply to a specific lab. You get into a program and then during your first year, you do rotations. So all of the programs I applied had this kind of a system. I ended up going to Duke and working and doing my PhD in the lab I was a tech in. But I think the importance of having research, whether it's in your undergrad, whether you do it in your gap years, is so heavily in the applications. The main part is a statement of purpose, and all you write there is about how good of a researcher you are or can be or will be. And so you have to have had experience. And then of course there's CV where you can put if you published papers or anything, but another part that is benefiting from having these research experiences is mentors. Because when you apply to these programs, you need 2 to 3 recommendation letters. So in undergrad, at least my personal interactions with mentors were not as close as during those 2 years, or even in graduate school. So whether you start thinking about this in undergraduate, when you're doing your undergraduate research or you're TAing for a professor. So for example, one of my recommendation letters was from a professor that I TA'd for 2 years of college. So he knew me really well, but it's something that you have to keep in your mind. Who are you? Who knows you really well and can write you about in a professional setting? And besides that, it's put your grades in, do the GRE, don't do the GRE. I don't know what's the current status on that. I did the GRE the year before COVID, so everybody canceled it and I did it for nothing, which was actually did not benefit me because I scored really well and it could have helped me. But so, I mean, yeah.
I'll,
Go ahead.
okay, sorry. I can speak to the medical school application process. I think really just reiterating that it takes like a entire village. Like it's not just you, and like make sure you have good people who can write letters of rec. And I think it's just what I would do differently if I could do it all over again is involve more people or use more resources. I think I was like, no, this is my application, I'll do it myself kind of thing, but like get more people involved and like, hey, can you read my personal statement? What does this tell you about me? And just like involve people and use the resources that your schools are giving you. I think that that would be my advice if I were telling myself to do it all over again.
And to add to that, also, after applications, you have all the interviews. So mock interviews, the same thing, involving people around you to give you mock interviews, because that made it so much less stressful. And I did it with my PI, and he asked me some questions that I would have freezed if I was asked. And actually, the interviews are not that bad, but there's sometimes someone who can ask a really deep question into your research. So if you haven't thought about it before, it's hard to answer it at that moment. So using people for mock interviews is that sounded bad, but involving people around you to give you mock interviews is a really good thing to do.
Wonderful. Thank you so much. Does anybody else want to say something else about that topic, or should we move on to the next question?
I mean, I think they've covered it pretty well. I would just say for masters, it's a lot of the same things, resume, transcript, letters of recommendation, statement of purpose. But I think it's a little less intense than PhD and MD applications. So like you don't really have interviews or anything for the most part.
Thanks for adding that.
And then sorry, I just wanted to add some advice for
Sounds nice, Cassie. Interviews. Sorry, Caroline, go ahead.
no worries. For like letters of rec, you should really reach out to your recommenders early, because like for one of my recommenders, he asked me to write a letter that I think he would write for me. So that took me quite a while to like come up with. And you don't want to be doing that like in your last month before all the applications are due.
Yeah, that's a good point. That happened to me as well. A lot of times the professors you're working with, they're super busy, and the process is you leave their contact info on the website when you're applying for the program, and they will send email to the whatever email address you left there. And sometimes it ended up in the spam folder or trash can, whatever. So it's a little bit intimidating to ask them to check those emails for you, but you gotta do it. You gotta do what you gotta do. At the end of the day, it's for yourself. So yeah, like Caroline said, that process sometimes can take months. So be sure to make really good communication with your recommenders. That's a really good point. Thanks.
Thank you all. Wonderful advice. Okay, let's move on to our next question. For those of you who have worked as engineers, could you talk a little bit about what that was like, especially if you have like compare and contrast to what it's been like in academia, and especially if you worked as a biomedical engineer?
I can talk a little bit more about engineering / research scientist in a more of academia setting. That's basically what I do. It's quite, to be honest, it's quite different from what I've been doing in my grad school. So for the grad school, most of the time you do research and basically all the work that your PI assigned to you. Your goal is to be able to publish articles as many as possible in a good way. But to me right now, it's quite different that more than half of my work duties more of regulation and administration related work. We have to deal with FDA, IRB. We have to, apply for a grant, all the grant resources, the NSF, NIH. That takes a lot of time, and it's quite understandable because that's where your salary is coming from, basically. So of course you want to be able to publish your study, but more of the time you learn a lot about management, project management, funding management, human resources, because you have more of a junior year student, undergrad or grad student. You have to be able to learn that how to optimize your team and how to assign a chunk of work to some other individuals. That's is something new I didn't know about, and I hope that's something can ring a bell for you. Other than that, in terms of the research itself, it's basically the same as grad school or PhD or for math student when you're doing a research year. It's quite similar, but it's more of a in a more of a timely manner because everything has a deadline. Oh, thank you.
Thank you. Drew, did you want to add something there?
Yeah, I will just say that I really enjoyed what I did. And it wasn't that, oh, I hated it and wanted to go back to school so bad. I did want to go back to school, not so bad, but I think that David made a lot of really great points. It's just like you get so much experience, and I think I said that previously, but it exposes you to things that are really integral to my current field, as far as, you know, a patent application or getting grants or just the administration things that you don't really see or are exposed to as a student. So I think that's really valuable. My role specifically was primarily like CAD modeling and design work. So I think that I really enjoyed it, and I really like the modeling aspect and coming up with new ideas and you know, new and improved devices. So I really enjoyed it, and I think that if I had to do it all over again, then I would still like go back to industry and then do school afterwards. So
Thank you. We have a question from the chat from Gabriella. She asks, for those of you who graduated with SMU's biomedical specialization, how useful has that been versus your advanced program and or work experience, being more specific? You guys can just unmute if you have a response.
I would say for my program, so my medical device design program, we're on design teams and we're trying to design this medical device, and it's a lot like what you would do in industry if you're an R&D. So having a mechanical engineering background has really benefited me because there are a lot of people on my team who have a BME undergrad experience, and they kind of all know the same thing, and they know surface level of electrical and mechanical, maybe a little coding, but not enough to really be useful in a design process, whereas I know a ton of mechanical engineering. So I'm really solid on all those aspects, whereas they're trying to like figure out more about electrical engineering and coding. So I think when you're working on a team, a multidisciplinary team, it's really useful to be a mechanical engineer or an electrical engineer. And looking at job applications now and internships, a lot of biomedical companies specifically want mechanical engineers or electrical engineers. So I think that'll be really nice on my resume and in interviews too. But it is nice now that I have that background to be in the BME program and get to see it all used in a BME setting.
Yeah, I think that's a really good question. I would like to add a little bit more. So basically, what you learn from college, no matter that's mechanical engineering, electrical engineering, or biomedical specialization, you learn a lot of stuff, but you don't spend a lot of time learning one aspect of the, you know, in the field. For instance, my background in electrical engineering, and there's circuitry, there's signal processing, and all kinds of different fields. They're close to each other, but not necessarily the same. So doing an advanced program or something like a gap year, like we just discussed, and in either a lab setting or professional setting, you spend more time on something really, really specific. So this problem, say you want to design this, you probably are exposed more to the design softwares, and if you do the, you know, softwares and the coding, you're more exposed to a certain say programming languages or IDE, stuff like that. And those already gives you that, I would say, leverage when you're interviewing for a position or for a higher or a more advanced program. Because people really want to get someone who is great at one thing instead of knowing a lot of stuff, but not, you know what I mean? So that's a really good point, and I hope that helps. And actually, I've been interviewing others for some of the junior members as well. What we really want is someone who can just come in and start work on something as soon as possible. So being able to master at least one either tool or technical aspect or theory will be really beneficial. But at the end of the day, it's up to you, and you can still explore more and more to find what you want to dedicate your time and your energy. Thanks.
Wonderful. So I think we have time for one more question if there's no other questions from the audience. So I will go ahead and ask, what do you wish you had known when you were an undergrad about college life? And also specifically, is there anything that you would have done differently in your undergraduate years, kind of hindsight being 2020? Like, was there a course that you wish you had taken, or maybe a professional organization you think would have been helpful to join? And you all can just unmute and answer as you would like.
I guess I'll just take start. So when I was in college, I really wish I knew more about the career path or career growth trajectory in certain field. Because at the time, like I said, I didn't even know what I'm going to learn in the future. But I'm getting older, and I'm more exposed to the industry / academia, all type of positions. And there's certainly some industrial job gives you more leverage to achieve your, I would say, personal or life goal, simply by paying you much, much more. It's kind of, I would say, not so ideal that most of, say, postdoctoral researchers, they have to follow the NIH standard, which is not a great pay, in my opinion. And those are even less than some of the entry-level industrial jobs. So if I had done anything differently when I was in college, I would definitely, like I said, spend more time on something I want to learn and invest myself and invest more of my time in those stuff. I actually listed a little bit of some examples. Those could be, say, statistics, some functional mathematics, the modeling, machine learning type of things. It's super hot nowadays. And or something like programming, coding. No matter what kind of industry, this is must have golden standard tool. And a matter of fact, I think more than 90% of the industrial job for engineering will have some sort of a technical coding where you type in the codes for certain questions. If you don't know much about that, it will be really intimidating. So be prepared for those, I would say, and find something you really love and spend more time on it. It will, over the time, it will pay back for sure. And another one I would say is, if I knew any of these things back in college, I would definitely spend less time in the frat house and more time in the library to basically submerge yourself into something. Like I said, at the young age, I mean, I've been there, I've done that. I didn't know what I want, but expose yourself to all kinds of different fields, you will definitely find something helpful. And that, I guess that's my thoughts on this. Thank you.
Would anybody else like to add anything to that?
I think it would have been helpful for me to know early on in undergrad that you can start a PhD and take all your classes, and then if you decide you don't want to continue, you can leave with a master's. At least in a lot of programs you can. So I learned that like a month before I graduated, and it was too late for me to consider PhDs. But if I'd known that well in advance, I might have done a lot more research on the different areas so that I could learn what research would interest me, like neural engineering. And then I might have gone for a PhD, and just if I didn't like it, then I'd get my master's, and that's a lot cheaper because
Yeah, but don't do it on purpose though.
no, I mean you
Give
don't
it a try.
go for a PhD knowing that you're going to settle for the master's. But if you think you really want a PhD and you're just not sure, then you can start the program and see if you like it and save.
Yeah, I mean, true, that technically true, but from like a PI's point of view, this type, I mean, technically or legally, you can do that no matter what, but it will be a huge impact on the PI's funding resource because everything's suspended and the funding could be revoked for some reason. And I've seen that happen before. So just don't do it on purpose. I know it's an option if you really don't if you don't really like what you've been doing, or you don't like the PI as a person, you can do that. But if you had a chance, go pursuing all the way to the PhD instead of like quit before that.
I mean, I agree. Don't start your PhD thinking you're gonna quit, but there's just a ease to it that you know that you're not committing to 5 years without nothing coming out of it, in case that really turned out to not be what you want to do. So I think knowing just that in the back of your mind is like, don't do it on purpose, but it might provide some stress relief that this is not going to be for nothing. And then 2 is, I agree that for PI it can be pain, but I think it depends on the place, because here we're supported the first 2 years by the graduate student in the school, not by PI grants. So it also depends on the place and the program.
I would just pitch in. I think we've had really great advice so far. One thing that I wanted to reiterate that David mentioned is I wish I had some coding skill, just because I think that I just didn't as a mechanical engineer, and I think it's super useful. And I'm like trying to learn Python, and it's janky and not great. And there are resources for me to do it, but I think some sort of formal training would have really benefited me for what I'm doing right now, or just like projects on the side kind of thing. And then the other advice that I would give is kind of 2 parts. One is you make your own advantages, like you make your own opportunities. Lila and I didn't see a biomedical engineering club, so we made one. So it's really like you make your own opportunities, and it's just really by getting out of your comfort zone, I would say, or reaching out to somebody who you necessarily wouldn't. Or if I think I'm interested in this, maybe I'll do some research and try to get a contact of somebody, reach out on LinkedIn or whatever. And then the second part would be that your situation is your advantage. I know I thought that, oh, SMU doesn't have a biomedical track. Like I'm not getting the training that I would at a different school. But kind of like Cassie said, because I was a mechanical engineer, it has helped me so much more because I have a more concrete skill set. So whatever situation you're in, or whatever skills that you have or experiences that you've gained through undergrad or throughout whatever your academic career, that's your advantage, and you can spin it in whatever way you want. So that would be my advice.
I will be also echoing on the coding. It's gonna be everywhere now, and just do it. Take the comp sci 101, just do it. But then the other thing I wanted to say is, I'm not very good at thinking about these. I wish what I did differently, because Drew mentioned this at the beginning of the panel, is that it seemed it was like these little connecting paths. Like one thing happened and then you kind of are like, oh, but this opened up and this is awesome. So I think my advice would be, don't get stuck in what you're supposed to do. I was pre-med until junior year. I really thought that I'm going to go to med school and that's going to be it, at least until one day I was supposed to shadow that summer. So I was supposed to do it. Because I mean, pre-med is hard. You have to keep this checklist of things you need to get done. So that's what I was supposed to do. But I got a wonderful opportunity to TA physics at by the beach the whole summer. And I loved teaching physics. And it was like, I don't want to give this opportunity up, but I'm supposed to do this thing. And then I was thinking, well, if I want to go TA, instead of walking by the profession that I will want to do, is it really the profession I want to do? So then that moment I was like, this is a great opportunity. This is what I want to do. So why keep doing these checklist things that I obviously don't want to do anymore? So my advice would be, just don't let those I wish I did come to the day where we're here, you know?
Wonderful. Well, I'd like to thank all of our panelists for joining us today and for your wonderful insights and knowledge and sharing that with us. Before we go, I'd like to announce that we are opening officer applications for next year. We have a lot of open positions. So if you're interested in becoming an officer, please let us know. We will send an email out with all the information probably this week. And if you're new and you've never been to a BMES meeting before and you'd like to learn how to join our organization, you can stick around for a few minutes afterwards and I can help you figure out how to do that. So that is it for tonight. Thank you all for joining us. Have a wonderful evening.
Thank you. Bye.